modeling with triangle shape detectors. In triangle shape detectors, we considered various type of detectors, smaller to larger shapes. Especially, we considered two complex detector here of hexagonal module and triangular module with 9 elements. These are the single shape detector in schematic diagram. Composite detector with 6 triangular shape detector modules and composite detector with 9 triangular shape detector modules. These are the schematic block diagrams. Here we see that a composite detector with 6 triangular modules of equal size. Here all the scenarios will be the same because when a gamma ray interacts with module A, the subsequent interactions, first interaction, second interaction, third and fourth interaction, the results we'll get will be the same, similar when gamma ray first interacts with B or C or D or E or F, the atmosphere will be the same. So similar type of calculations will be there. So we have considered here only the one calculation that will be multiplied by 6 for total consideration. And from here we also found out the peak to total ratio and corresponding add back factor. Now in a triangular type composite detector with 9 triangular modules, here also we considered the same case. First gamma ray interacts with module A, and after first interaction we get the second case, second interaction, and this is the third interaction, and that is the fourth interaction in pictorial form. And these are the actual calculation in, that was in fast interaction. It will be difficult to see from backside, but following the same procedure as we done in our Clover detector. One part is absorbed, one part is scattered from the detector module and scattered to neighboring parts, all are elaborately shown in our calculations. And after second interaction, the calculation, third interaction and fourth interaction. When interaction increases, the calculation gets some difficult. So we considered only fourth interactions, and these are the pictorial representation of the two other configurations when gamma ray first interacts with module D, and here gamma ray first interacts with module E. And subsequent, there will be similar type of calculations for each of these two configurations, but here we skipped the detailed calculations. And final result calculations we have shown here: the total absorb counts and peak to total ratio and add back factors. For more complex configurations of detectors, single parameter model is somehow gets more complicated. Its calculations becomes more complicated. In those cases, we use the two parameter model. Here, another parameter is introduced, that is Z, which is the ratio of covered lateral surface area to total lateral surface area. Introducing this parameter Z, we see that these calculations become much more simpler and we get this approximately similar results. So, introduction of Z, uh, we modified our calculations a little bit. Here, absorbed events with nx, scattered events n into 1 minus x, and introduction in adjacent modules. Here we introduced the parameter z, which is z into n into 1 minus x, and escaping from events from the composite detector is 1 minus z into n into 1 minus x. So this is, in this way we developed a probabilistic method with two parameters. One is x, another is z, and fourth, first, second, third, fourth calculations has been performed using this two parameter model. And here we see different type of combination of detector modules, smaller to larger shapes. We started from very beginning with k is equal to 1, that is one detector module, and subsequently we increased the detector modules number. and different geometrical configurations also we have considered. And here the mu is the common boundary of the detector modules in the composite detector. Each configuration values of mu and z are shown in this way. The configurations inside dotted box have same value of z. Here we see detector composite detectors with k is equal to 1 to 10. Next, here we considered with k is equal to 11 to 15. As the detector modules number increases, we see that different combinations of detector modules is possible, and each combination they will have different number of mu value and corresponding z value. Here k is equal to 16 to 19. So for k is equal to 16, so we get different type of combinations, arrangements, and for each arrangements with separate value of mu and corresponding z value will we get. And similarly, k is equal to 19, we get so many type of configurations. For k is equal to 20, there are also different number of configurations and corresponding value of mu and z. In this way, we considered up to k is equal to 25. That is a composite triangular shape detector with 25 triangular detector module. With all this, we have here shown the add-back factor as a function of probability factor absorption x, probability absorption x. And we observed an increasing trend similar to the ones for the Clover and cluster detectors, whose results were experimentally verified. The maximum value of the add-back factor predicted from our model is nearly 1.4 for k is equal to 2. This is clearly observed, almost doubling of the add-back factor for the k is equal to 24 detector compared to the k is equal to 2 detector. So as the detector number increases, the value of add-back factor also increases, and when k is equal to 24, it gives double the value of add-back factor which we get from k is equal to 2. And here we see that as the detector module number increases, we get different combinations of the detector modules, which also gives us different values of mu and z. We have here considered the different values of z with those type of configurations, and see that when detector module number increases, we get different values of z. That's why in 25 k is equal to 25, we get 8 number of z values and corresponding add-back factor. The variation of the add-back factor is shown for complex detector having k is equal to 1 to 25, for absorption probability x is equal to 0. For the composite detectors with k is equal to 2, 3, 4, 6, 12, 18 and 24, for each value of k we have considered the configuration with the maximum value of z and calculated the add-back factor. For composite detectors with large number of modules in compact geometry corresponding to maximum value of z, there is more add-back, resulting in greater improvement of the add-back factor. So this is the new probabilistic approach of modeling composite detector consisting of triangular shape detector modules in add-back mode has been presented. Considering isotropic scattering and partial or complete absorption of gamma rays, expressions for the add-back factor and the peak to total ratio are obtained in terms of the absorption probability x in a single detector module and the ratio of covered lateral surface area to total lateral surface area z of the composite detector consisting of k detector modules. We have calculated the add-back factor for several composite detectors in their compact configuration. The general trend of our predictions matches with that of the Clover and cluster detectors.